Hi, welcome to the IMVT facility of 3D printing here in Karlsruhe. We are standing in front of our SLM Realizer SLM 125. It's a selective laser melting machine. We are printing now actually a fluid guiding or distributor system. It's starting since yesterday at 11 o'clock and will be finished today in the evening. You can see here in the build space behind this lid, there is the powder bed. Maybe we can have now a closer look at it. You see the wiper going up and down all the time, bringing fresh powder. In between you see the laser melting up all the hatch lines and the contour lines for it. This system is also equipped with internal powder cycle. This means we have like a vacuum cleaning system inside. We have here two gloves, so we have no contact directly with the powder, and then we remove the powder, getting it sieved and putting it again into the machine. This was now the basic principle of the machine. Now what are we doing here? Here we are printing different structures, metal pieces we need for our research work. We are getting it, we have, for example, I'm a PhD student, I'm doing distillation units, additive manufactured distillation units, compact units. We can have afterwards a look on it. Or we get in print jobs from colleagues not working directly on additive manufacturing, but you coming with challenges for us, saying we need a part for this or that, and then we are looking if it's possible to print it here, and then we print it. So we are more or less one of the fabrication units here, and we are using additive manufacturing for parts too complicated to manufacture in the classic way, or doing like rapid prototyping, so we can increase the production times with additive manufacturing by using especially high complex parts we can print overnight, so we can increase our research output by using additive manufacturing, because we are using, like we can, for example, I'm printing over a weekend 4 parts. In the week I'm testing it. After 1 week I have the results, so I can start in the weekend with the new print job. So we have a really fast manufacturing cycle, so we can really edit the geometry and not just the process parameters. So we can stick for geometry and maybe go also for simulation-based designs. So now look at some parts we printed recently. For example, I have here one of our bigger parts. It's a fluid distributor for a reactor system. It's making from 4 channels 256 small channels. So we have like a fractal structure directly going to the micro channels. So this is also one of the pieces you can show the new design freedom. It's just the metal you need. It's a wall thickness of 2 millimeters, and you can see as low metal consumption as needed. We have also printed like honeycomb structures. This is an example for thin-walled parts. So we have a lot of small channels inside it. It was just a test piece. It's not using really the advantage of additive manufacturing because it's straight channels, but you can see it's possible to print really thin walls. With thin walls you can also do like something more fancy, like this fluid guiding elements we designed for heat exchangers. As you can see, it's nearly impossible to manufacture it without additive manufacturing. It's distributing in a tube, it's distributing the flow always from the wall to the inner and out, so it's like a static mixer. And it's completely optimized for additive manufacturing. It's coming like this on the build plate. You have to remove the powder and then just take it like this from the building plate, and it's ready for use. So no complicated machining afterwards. You can use it as printed. And now, for example, we have here a bit more complicated and a completely printed, 3D printed distillation unit. We manufactured here. You can see everything is included. The internal structures printed here. You have the inlets, outlets, channels, and the connections. As you can see, it's always optimized for 3D printing, because you see there are no support structures above here. You have on the building plate, you just remove it from the building plate, and you have to mill the threads, and then you are finished. So this is one of the things you have always to have in mind. Optimize your part for 3D printing. Don't try to print parts made for milling. Redesign it, and then you have the real advantage of 3D printing. So now we are at our second printer, and our newest printer. It's a digital metal P2500 binder jetter. It's one of the newest systems we have here, and we use it as a second option to the selective laser machine, because with binder jetting you have different restrictions from selective laser melting, because in selective laser melting you have always the issue you're directly melting the powder. So you have on overhangs, you have problems. You can't print, for example, a 90-degree angle. This is possible with binder jetting. What's binder jetting? Binder jetting is one of the oldest 3D printing methods. You have a powder bed as you have it on the selective laser machine. You have also a powder applicator who is bringing the new powder on every layer, and you have a print head. And what you're doing here is now, in comparison to the selective laser melting machine, you're not melting it, you're just binding it with the ink. You see it here, it's the blue ink, and you are gluing the powder together, so you have a green body. Afterwards you have to cure it, depowder it, and putting it in a sinter furnace, and then you have your final part. So you're removing the thermal step you have in the selective laser machine directly through the sinter oven. So you have here no issues on the thermal side. So you have no problems with internal stresses, no problems more or less with overhangs. So we have now two possibilities to print parts, and every machine has its sweet spot. So we can decide on every new part which machine we have to use or we can use. For example, binder jetting has a sweet spot in the size of a golf ball parts, with also internal channels, but the depowdering is complicated. What's more easy at the selective laser machine, but there you have always trouble on the thicker parts and so on. So here you can go also for a bit thicker parts and print them. So, and also one idea is here to print porous parts, complex porous parts, by not sintering it completely, just sintering to some extent. One thing we choose, like for example this printer, it's also with a really high resolution. You can see it here. It's a massive stone, so everything is also designed for high accuracy as we want it, because we are printing microstructured systems, so resolution is one of our main goals by printing it. Yeah. Now I'm standing in front of the depowdering cabinet. After printing at the binder jetter, you have a build box full of powder, and you cure it, so the ink is going to be hard, and afterwards you have to remove, before sintering, all the powder. And this is done here in this closed cabinet, so you are not exposed to powder. And we use compressed air to remove the powder from the parts, and after this step it's going for the sintering. So now maybe we can have a look close inside when I'm depowdering some of the parts. So we have now one of the parts you have seen before from the selective laser machine, this flow distributor for the reactor. It's still more or less in the powder, so we're using now compressed air to remove slowly all the powder from it. So now we have also always think about the internal channels and getting rid of the powder there, so we have to go through every channel and make sure that all the powder is removed, because in sintering all loose powder will be metal, dense metal, so you can't use it as you want. So always make it sure. Yeah, and so this is also one important step at binder jetting, depowdering it, especially if you have internal channels, because it can be a bit time consuming, but it's always a question between the advantage and disadvantages of the system. So depowdering is a bit easier in the selective laser melting process, but you have always the overhang issue and the thermal issue, so choose wisely. So after this step, if all the powder is removed, we put it on in the sintering oven, and afterwards it's finished, and we have our final part, and look if it's working or not, and then we can try maybe a second time, or if we are lucky, it's working in the first round. So now look at some parts we printed with this printer, and I can show you some advantages of the printer or the technology, and maybe also I show you some hidden things or faults of the system. So for example, we have here really a small part, quite complex. If you look at it, it was printed also in one step and sintered, and it's worked quite good. We tried this also on the selective laser machine, and there it was more complicated because of the overhangs and so on. So, and the quite massive metal. So this is really a good part. Also thin walled structures are possible with the binder jetter. So for example, this part, it's also a wall thickness around 200 to 300 microns. For example, also we printed like a key. There went something wrong at the sintering stage, so it bended a bit. But I think if it's a problem you can solve with better support in the sintering process. But it's showing you also the cycle. You print something and then you learn from it. Here we have also a micro heat exchanger, also printed in one step. Here the difficulty is to get rid of the powder in the internal channels, but the outer surface and so on is quite good. And now we have here a part, it's more or less the same I have shown you before, the distillation unit. And now if you compare the designs, this design was, I showed you before, was optimized for selective laser melting, and now we have a design a bit more optimized for binder jetting. You see we have not this inclining surface, we have just a flat top. So you see we can print and sinter this structure, and it's working fine. But as I mentioned, there was also a problem. In the depowdering step I lost one of the connections because the wall thickness was too low. So it's always, you have to choose right which printer you use, and you are in the best situation if you can use from different printers and using them, or technologies, and using this one which is the best. So 3D printing, it's not one machine and one printer, it's a whole line of tools you can choose from, and always use the right tool if you can. What attracted me in this field, I think it was one thing for sure, was it's a new technology, it's a new field, you can do some first steps on it. Also I think the creativity you can explore by using 3D printing. You can really think about things and then print it and get it. I think this is one of the attractive things in this field. I like it most. Designing it at the computer and getting it, it's always like, if you did it the first time, it's like, yeah, you're really happy to see what you thought about now in a final part. I think it's not so difficult. You have to learn the CAD system, and you have to learn the design rules and restrictions of additive manufacturing. And the best thing to learn is doing it hands-on, using the machines, getting parts printed, and also getting parts printed who are not working. Then you can see what went wrong, what did I make design wrong, and then so it's getting a closed loop. Always you're learning by printing, using some software tools, you're always learning, and if you're happy by always learning, you will learn quite fast also in this field. So don't be afraid, use it, and then I think you will get the best experience if you printed something.